Hi everyone and welcome back to my channel. Today we are going to discuss the numericals from the H.C.Verma textbook for the chapter Newton's Laws of Motion. So the first question that we have in the exercise section is as shown here. A block of mass 2 kgs, mass is 2 kilos, placed on a horizontal frictionless surface is pulled horizontally by a constant force F. It is found to move 10 meters in the first 2 seconds. Okay. And we have to find the magnitude of the force. So first, what is the formula for force? Force is equal to mass into acceleration. So from the Newton's second law of motion. And now we have to, so we have the mass and now we need to find out the acceleration. So S is equal to ut plus half at square. U is 0 because it was initially at rest. Half into a into t square. T is 2, which is 4. T square is 4. S is what? S is 10 meters. Okay. So what would that be? This is removed. 2 is done. A is equal to 5 meter per second square. A is equal to 5 meter per second square. Now if we put all the values that we've gotten into the formula, we get 5 into 2, which is equal to 10 newtons. So this is basically the force that was applied, and the magnitude of F is basically 10 newtons. Okay, so let's look at the next question. In this question, we have a car moving at an initial velocity of 40 kilometer per hour, right? That is one thing. Now it is stopped by applying brakes in the next 4 meters, which means that the final velocity is 0 because we are stopping it. Okay, 0 kmph, and the car weighs around, it weighs 2000 kilos. Okay, what is the average weight or average force applied on it? So we are supposed to find out the force. Now we know that when we calculate force in newtons, the acceleration is always in meter per second square, right? So this initial velocity is in kilometer per hour, which we need to convert it into meter per second square. So 40 into 5 by 18 will give us the speed in meter per second square, right? So what would this be? Let me just use a calculator. Value is basically 11.11 meter per second. Okay. Now, the next thing that we need to do is calculate the acceleration. So what is the distance acceleration relation formula? V square minus u square is equal to 2as. Now we see if we substitute these values in here, v is 0 minus 11.11 whole square is equal to 2 into a into 4 meters, right? Now if we simplify this, we get our a to be minus 15.42 meter per second square. This implies F is equal to m into a, which is the Newton's second law of motion. M is 2000 kilograms and acceleration is minus 15.42, which is, let's just take the magnitude, 15.42 meter per second square, and therefore the acceleration is equal to 30800 newtons. Okay, so this is the total force that is being applied by the brakes on the car. And if you want to simplify this further, you can write it as 3.08 into 10 to the power 4 newtons. Okay, so in this question, we have a TV picture tube where electrons are ejected from the cathode with negligible speed. Okay, so which means that u is equal to 0 and reach a velocity of 5 into 10 to the power 6 meters per second. So 5 into 10 power 6 meter per second. In traveling 1 centimeter, so S is equal to 1 centimeter, which is equal to 1 into 10 to the power minus 2 meters, right? Assuming the motion is a straight line motion, find the constant force that is being exerted on the electron if the electron's mass is equal to 9.1 into 10 to the power minus 31 kilos. So again, we are going to use the formula of F is equal to mass into acceleration, which is the Newton's second law of motion. So what is our M here? M is this 9.1 into 10 to the power minus 31. The mass here is that, and our acceleration is what we have to find. So S is equal to, okay, so we'll use, which one will we use? We have velocity and this distance, which means that we'll use V square minus U square is equal to 2as. So let's bring A2 and S to this side so that we have A here. Okay, and now if we plug in all the values that are there, U square is 0, so let's just strike that off, and V square is 25 into 10 to the power 12 divided by 2 into 10 to the power minus 2, right? 10 to the power minus 2 meters is what the distance it is, right? So this gets cancelled to 2 to 10 to the power minus 10, sorry, 10 to the power plus 10, or no, it's gonna be 10 to the power 14, right? Because this 2, if it minus 2, if it comes to the numerator, it becomes 14, and this gets cancelled to 12.5. So the acceleration finally, the acceleration is equal to 12.5 into 10 to the power 14 meter per second square. This implies the acceleration is equal, the force is equal to mass into acceleration. This implies force is equal to 9.1 into 10 to the power minus 31 into 12.5 into 10 to the power 14. The total final value that we get is basically it's basically, if we calculate this whole thing, I'm using a calculator here, so it comes out to be 1.1 into 10 to the power minus 15 newtons. Okay, so this is the final answer, or the final force that is being exerted, or final force that is being applied on the electron. Okay, so this was the third problem. Now let's go ahead and look into the fourth problem that is there. Okay, a block of mass 0.2 kgs is suspended from the ceiling by a light string. Okay, so these questions which have a lot of information, it is better to draw the diagram. A second block of mass of 0.3 kilos is suspended from the first block using another string. Find the tensions in the two strings. Take G as 10 meter per second square. Okay, so in this case we have to draw these diagrams individually as well to understand better. 0.3 kilos, and we draw the forces that are there. So let's say this has the weight pulling it downwards, that is 0.3 into G. Okay, and we have a tension. Let's say this is string 2 and this is string 1. So this will be T2, right? This will be the second block. Now looking at the first block, we have a 0.2 G force downwards and a T2 force downwards and a T1 force upwards. Now let us first use this and calculate and get the equation. So T2, it will be 0.3 G, G is 10, so 3 newtons minus T2 is equal to 0, which implies T2 is equal to 3 newtons. Okay, this is the first equation that we have, or the first result that we are getting. And the second one is 0.2 G, which is basically 0.2 into 10, which is 2 newtons, plus T2 is equal to, or rather T2 minus T1 is equal to 0. So T1 is equal to 2 plus T2, which is equal to 2 plus 3, which is equal to 5 newtons. So the force in the first string S1 is 5 newtons, or the tension in the first string S1 is 5 newtons. The tension in the second string S2 is 3 newtons. So this is the final answer that we have. Okay. Now moving on to the next question, the fifth question. Two blocks of equal mass m are tied to each other through a light string and placed on a smooth horizontal table. Okay, so two blocks of mass m are connected by a very light string and are tied to each other and are placed on a smooth horizontal table. That means there is no friction here because we have a smooth table. One of the blocks is pulled along the line joining them with a constant force F. So the force here is, let's say, is F. Find the tension in the string joining the blocks. So let us call the tension T. Okay, and we have a mass m here. Okay, and now let us write the equation. Okay. First, take each figure or each object individually. We have a force of mg downwards. We have the r force which is there upwards. We have the force F pulling this way, and we have the force tension pulling this way. Okay, and if we take the second block, also we have the similar kind of thing, right? We have a T force this way, and we do not have anything towards the leftward direction. We just have the mg downwards and the resultant r upwards. Mass into acceleration here, the force, the resultant force, and we obviously will have a mass into acceleration here as well. Okay, now we do not have anything to do with the vertical axis, because our object and the force that we want to find the tension is in the horizontal direction. So let us balance the forces in the horizontal direction. Okay, so F, let's first take this object, F minus T minus ma is equal to 0, which implies that F is equal to T plus ma, right? Which implies T is equal to F minus ma. That would be a better equation for us. And looking at this object now, we have T is equal to ma, right? So in the place of ma, if we replace it with T, this implies that T is equal to F minus T, which implies that F is equal to 2T and T is equal to F divided by 2. That is the final answer. The tension in the string that we have is equal to the force that is being applied divided by 2. So that's the final answer here. Okay. Now moving on to the next question. So let's look at the sixth question now. A particle of mass 50 grams is moving on a straight line. It's moving on a straight line. The mass is 50 grams. The variation of speed with time is shown here. Okay. Find the force acting on the particle at t is equal to 2, 4 and 6 seconds. Okay. So at 2 seconds, the velocity is 5. Right. So which means that basically we have the velocity versus time graph. And in a velocity versus time graph, what is the acceleration? Acceleration is basically the slope of the graph. Right? So at t is equal to 2 seconds. What is the slope of this graph? The slope of this graph is basically the perpendicular by height. The perpendicular by base. Okay. So the perpendicular is 15 divided by the base is 3, which means that it is 5 meter per second square. Okay. Therefore, the force will be equal to, force is equal to m into a. M is 50 grams, which means that it is 0.05 kilograms into 5 meter per second square, which implies that it is 0.25 newtons. the force being applied at t is equal to 2 is 0.25 newtons along the direction of motion. Now, moving on, let's go to t is equal to 4 seconds, right? Okay, so t is equal to 2 seconds पे 0.25 newtons is the force. Let's keep this aside. That's the first part of the answer. Now, if t is equal to 4 seconds, this is 4 seconds. So the acceleration is what? It is the slope of this line. The line is a horizontal line parallel to the x-axis, which means that the slope is 0, which means that the acceleration is 0 meter per second square, which implies that force is equal to mass into acceleration. Mass 0.05, acceleration 0, which implies that our force is 0 newtons. So T is equal to 4 pe, force is 0 newtons. Now, let's look at t is equal to 6 seconds. So t is equal to 6 seconds pe we are here. So what will be the slope? The slope will be the perpendicular by base again. The perpendicular is basically 5. Okay. And the base is, sorry, perpendicular is 15 and the base is 8 minus 5, which is equal to 15 by 3. This is 5 again, right? So basically it is 5, but it is in the downward direction, so it is going to be minus 5. Okay, so the slope is now minus 5, that is minus 5 meter per second square. And now if you calculate F is equal to ma, which implies that 0.05 into minus 5, which is basically minus 0.25 newtons, which implies that the force is at the force being applied on the object at the 6th second is basically 0.25 newtons, but in the opposite direction, because the force is a negative force. Okay, so in the opposite direction to which the object is moving. So that's what your answer should be. 0.25 newton along the direction of motion, 0 newtons, that is no force at all, and 0.25 newtons in the opposite direction to the motion. So this is what the answer for this problem should be. Now, moving on to the next question. So now looking at this question, we can understand that two blocks A of mass ma and B of mass mb are kept in contact. Okay, they're kept in contact on a frictionless table. Okay. The experimenter pushes the block A from behind so that the blocks accelerate. If the block A exerts a force of F on block B, what is the force exerted by the experimenter on block A? Now let us draw the diagrams for each of these blocks. So MA, okay, MA will have a force of F on it, and we will have a force of, okay, we will not have a force of F here. The F is on the blocks. Okay, block exerts. Okay, so it'll be F. A force of F is being exerted here. We have a force of MAG upward of R, and we have a force of experimenter that is being exerted in this direction. So when this is the case, so let's draw a similar diagram for MB as well. You have MBG, you have your R, you have your F that is being exerted in this direction, and you have your MA. MBA in this direction. Okay, right. Now let us write the equations. We do not need the vertical axis because the acceleration is not in that direction, and we want to calculate the force E here. Right, so I just missed that. MAA and MBA, and we have a force of F in this direction. Now if you write the equations, you have MAA plus F minus E is equal to 0, and in the second case you have a force of MBA minus F is equal to 0. So MBA is basically equal to F. That's one equation you have. Okay, and from the first equation that we had, you will get E is equal to F plus MAA, right? You can replace A by F by MB from the equation 2, from this equation, F by MB. So F plus MA into F by MB. This implies if you take your F common here, 1 plus MA by MB is equal to E. This is the final answer. So the force exerted by the experimenter on A is basically your F of 1 plus MA by MB. Okay, so this is the final answer. Now moving on to the next question. Okay, so this was the 7th question in your exercises part. So now let us look at the 8th question here. So the 8th question says that we have raindrops of radius equal to 1 into 10 to the power minus 3 meters, because 1 millimeter is 10 to the power minus 3 meters. Then we have a mass of 4 milligrams, which is equal to 4 into 10 to the power minus 3 grams, or 10 to the power minus 6 kilograms. Okay, that is done. Then they're falling with a speed of 30 meters per second, which means that the initial velocity is 30 meters per second on the head of a bald person. The drops splash on the head and come to rest, which means that the final velocity is 0 meter per second. Assuming equivalently that the drops cover a distance equal to the radii on the head, so which means that the distance is equal to the radii. And the radii is the radii of the radius is what? 1 millimeter, which is basically 10 power minus 3 meters. So this is the data that we have. What we need to find out is the force exerted by each drop on the head. Force is equal to how much? Force is equal to mass into acceleration. We already have the mass. We need to find out the acceleration. We have the V, we have the U, and we have the S, which means that we will be using the formula V square minus U square is equal to 2AS, where A is equal to V square, which is 0, minus U square, which is 900, divided by 2 into S. S is basically 10 to the power minus 3. So if we take this to the numerator, it becomes 10 to the power minus 5. So it is basically minus 9, which is minus 9 by 2, which is minus 4.5. Okay, so we have minus 4.5 into 10 to the power 5 here, which is the acceleration, meter per second square. Now if you find out the force, which is m into a, m is what? 4 into 10 to the power minus 6 into minus 4.5 into 10 to the power 5. Because we are calculating the force, we calculate the magnitude here. So 4.5 into 10 to the power 5. So if this gets cancelled, we have 10 to the power minus 1, right? And 4 into 4.5 is basically what? 18.0. 180, or rather it's 18.0 into 10 to the power minus 1, which implies that the overall force is 1.8 newtons, right? So this is the final answer that we have. Each drop is creating a force of, or exerting a force of 1.8 newtons on the bald man's head. Now, moving on to the next question. So the next question, or the ninth question, is a particle of mass 0.3 kilograms is subjected to force of F, okay, subjected to a force of X, is subjected to a force of F is equal to Kx, okay. So force F is equal to Kx with a K of 15 Newton per meter. Okay, what will be the initial acceleration if it is released from a point where x is equal to 20 centimeters? Okay, so F is basically equal to Kx. F is also equal to ma, which implies Kx is equal to ma, which implies, what is K here? K is 15 Newton per meter into x is 20 centimeters, which is 20 into 10 to the power minus 2 meters. Okay, this is equal to 0.3 mass into acceleration, and this 0 and this can be cancelled. This is 0.3 is nothing but 3 into 10 to the power minus 1, so this can be cancelled, and 3 5s are 15, so which is basically 5 into 2, which is equal to 10 newtons, right? So a total of, sorry, 10 meter per second square. So a total of 10 meter per second square would be the acceleration when the object of mass 0.3 kilos starts from rest. Okay. Also, another important thing to note here is that this question mark here was actually a minus. So therefore, it's equal to minus kx. So therefore, our here we have a minus here, and the kx is also minus. Therefore, our acceleration will be minus 10, which implies that the acceleration is in the negative direction or in the opposite direction. Okay. Now moving on, let's look at the last problem of this video, which is the 10th problem. So I'll be making each video with 10 problems so that it becomes easier for you to practice, and therefore the next problem is the last problem for this particular video, which is the 10th problem of the exercise section. So let us first write down the equations. Okay, if we displace a distance of x, okay, let us say the block is displaced to the left with the distance of x. Okay, so if it's displaced to the left or the right, either ways the overall force will be the same. So let's say we are pulling it to the left in the situation. So when you pull it to the left, you will have a k1x force in the rightward direction, and also a k2x force in the rightward direction because of this spring. So because of k1 spring, because we are compressing the k1 spring, right? So when you're compressing a spring, it will try to expand. So when the spring is trying to expand, then the force is in the rightward direction. Similarly, when the k2 spring, you're elongating it, you're stretching it. So when you stretch it, it will try to compress. So when it will try to compress, the force is again in the rightward direction. Therefore, k1x and k2x, both forces are acting in the rightward direction only. Now, if you calculate or say that this direction, you will have your MA to balance it out. So MA will be equal to k1x plus k2x, which implies that A is equal to x common k1 plus k2 divided by m. So the overall acceleration will be x into k1 plus k2 divided by m meter per second square, and this is the final answer for the solution. So I hope you found this video helpful, and also if you did, please do like, share and subscribe to my YouTube channel, and I'll come back in the next video with the next 10 with the next set of 10 problems, and we will discuss them. And I hope you are finding my session very interesting and helpful. Thank you.